All right, let's go ahead. Okay, welcome to the Spack BOF, everybody. I just wanted to give some updates on the progress on the Spack project here. This is joint work between me, Greg Becker, Tammy Dahlgren, Peter Scheibel, Risharda Butler, and Sergey Schudler. All of us are at Livermore. And we also have we have a lot of other core developers who've collaborated on this, but those are the folks who are working under ECP. For folks who are here who don't know what Spack is, it essentially allows you to manage the dependencies of large HPC simulations. I think as you saw from the plenary, apps are getting way more complicated. So this is showing a sampling of HPC applications like MFEM with 31 packages. LBAN is a machine learning tool that has 71 packages and 188 dependency edges. And then things like MUMI that integrate lots of different types of simulations and scheduling and machine learning can have 100 or more packages. If you think about what that means for the package manager, and if you think about other package managers that are out there, like the one in your Linux system or the Conda or other systems like that, most of those things assume sort of a one-to-one relationship between source code and binaries. They think there's one way to build things, which is good for reproducibility, but it's not great for performance optimization. And they assume that you want portable binaries that can work everywhere, so they're distributing one thing for all systems, which again means that you can't really optimize things, and that the tool chain's the same across the ecosystem. HPC violates all of these assumptions, and code is typically distributed as source, and people build lots of different versions of packages. They also rely really heavily on system packages and the host libraries like the MPI and the GPU libraries on the system. And HPC codes span multiple languages. So we're trying to address this kind of ecosystem and build a tool that can distribute for all the machines that we care about within DOE and beyond. If you look at the types of problems people encounter with these codes, this is MUMI again, the big code with 98 dependencies. Just adding a new version of a package in something like this can be an exercise. So the team needed a new version of Keras. That ended up needing a new version of Theano, which needed a new version of NumPy. These are machine learning packages that sit on top of this sort of Python numerical stack. NumPy depends on OpenBLAS, and the team was using OpenBLAS from the system. This is on Summit. And the disconnect here between NumPy and the system OpenBLAS really cost them a lot of time. They had to tweak things and make sure that all of these things built with the system OpenBLAS. And this is the kind of dependency problem that we're targeting with Spack. We're trying to solve these kinds of issues and make it easier to deploy different versions of things that work on different systems. Spack enables that by having parameterized packages. It's not like pip or something like that, where you just have one version of something that gets installed. If you clone Spack and install HDF5, you can install it however you want. You can say, I want 1.10.5, I want that with this compiler, I want the threads, I want flags, I want a particular architecture, and you can customize the dependencies of that installation too. So it makes it possible for all the different builds that we want to do for HPC to coexist, and moreover for code teams like applications to build their dependencies the way they want them. It also generates modules, which is useful for facility deployment, and it's used to deploy E4S at facilities and to generate modules there so that humans don't have to write them. It allows environments sort of like Conda and virtualenv, so you can have multiple separate contexts in addition to having lots of different installations. You can have sort of projects where you have lots of different packages within them. And we're providing more and more DevOps features built on top of that. So things like CI, container generation, and other things to support developer workflows. It's used on some of the fastest supercomputers in the world. This is Fugaku. It's also used on Summit and Sierra and lots of other different systems. And important to this meeting, Spack is critical for ECP. If you look at the dependency graph by producer in the dependency database for ECP, Spack is the most dependent on project in ECP as an important dependency. It's not critical, but it's used by all the different packages specifically to integrate software into E4S and to get it deployed out on the facility systems. So it's a key sort of backbone of the ECP software ecosystem. We're working to support GPUs and other aspects of the new hardware showing up at facilities. Their most recent 0.16 version of Spack had more support for vendor compilers. So we introduced one API in VHBC and AOCC as supported compilers in Spack with help from vendors. So that's been nice to have their support. Tammy Dahlgren, who's on the call, is leading an initiative to use Spack to test E4S on ECP early access systems. And we are using the Spack test feature there to ensure that packages can build and that they also work on those machines. And then GPU integration across the stack is an ongoing focus. If you look at the past year of contributions to Spack, contributions to packages continue to rise. This is showing the number of lines in Spack packages by the organization that contributed them. You can see that we had a uptick in the contribution rate in 2020. So things started growing faster, and I think that's a trend that's continued over time. And we hit an all-time high of 3,700 monthly active users on the documentation site, and this is showing where those users were in the world, at least according to Google Analytics. And so you can see that we span all the continents now, which is pretty cool. That leads to a pretty high contribution rate in Spack, and to help with that, it's been nice to see an increase in industry contributions to Spack. So Fujitsu and Riken have contributed a whole bunch of packages to support ARM. That was to support the Fugaku effort that's over the past year and a half. AMD has started contributing ROCm packages, and we've even had discussions with them about how to sync up their contributions with new chip releases and new GPU releases. They basically want to have new versions of ROCm in Spack on day of release. Intel's contributing one API support, or at least helping with it, and NVIDIA has helped out within VHBC compilers. We've gotten contributions from ARM and Linaro, again, to support the ARM architecture. And then we have an ongoing collaboration with AWS to support our cloud builds. We are working on it you'll find out later, but we have CI in Spack now that can run on pull requests. And we're working with AWS to support the build farm for that runs in the cloud and ensures that Spack packages keep building over time. We talked about this at Supercomputing, but we did have a survey last year that had some pretty interesting results. So if you want to go and look at the Spack survey results, go to spack.io. There's a Spack user survey article there that you can read through, where we have a write-up of the results from the survey. 169 people responded, and I think the takeaways are that people like Spack in the community. They would like to have clearer docs, although they're still good. And package stability is a big deal. So if you look at the sort of overall results down here, that's what we got out of it. Concretizer features and developer workflow features seem to be the most wanted improvements, and it's good because those are things that we're actually actively working on, and I'll talk about that a little bit later. If you look at the survey results, and there's a lot more than this, but one thing to take away is that Spack is about 36% ECP. In terms of, at least from the people who responded to our survey, this is what we got. We asked what GPUs people expected to use with Spack in the survey, and in the broader community and in ECP, NVIDIA is obviously, most people want to use NVIDIA GPUs. Within ECP, as you would expect, there was much higher demand for AMD and Intel GPUs, and so like over 50% of people in ECP were expecting to use the Intel GPUs, and over 80% were expecting to use AMD, versus 50% AMD in the community at large and about 25% Intel. So that's to be expected, but it's nice to have confirmation on something like this in the survey. Compilers were also more diverse within ECP than within the rest of the community. So we divided the results in the survey up between ECP and the total community. So if you go to the website and read the full results here, you can do some more comparative analysis, and I think it's pretty interesting to see how the trends pan out. We have introduced, to support this testing effort within ECP, a new feature called Spack Test that I think you've heard of, especially from Ryan's talk this morning. Essentially, this allows you to put tests in your Spack package. So it's just a normal Spack package. You can say, here's some extra stuff I want to keep around for running tests if there's something from your build environment you want to keep. You can add a function called test to your package. and write some code to compile or really do whatever in there, and then run a test against an installed version of your package. The cool thing about this is it enables a command called Spack test. So if you want to test an installation, say right after you install it, you can do that. You can say Spack test that thing. If you want to test it later, after you've had the thing running on the system for a while, maybe you want to see if it works with the latest OS update on the system, you can run Spack test again. And it's environment aware. So if you run Spack test within an environment, it'll test all the packages in the environment. So you can quickly vet your stack to make sure that it's still working on a machine. Tammy has this chart of all the different packages that she's working on. So we're working with code teams actively to help them to get their packages, to get test methods added to their packages. And we've already got a lot of codes done. So there's over 20 that are either done or in progress. And we're going to be working with these other teams to get the whole of the E4S stack in so that we can run the tests automatically whenever we deploy the thing on early access machines. It's not hard to write a test. You really just have to put a little bit of logic in your function. A lot of packages just run part of their existing test suite or run something fairly simple in there. We just want a smoke test to make sure that the package works on the machine, and if it needs to use the GPU, that it does. So please contact Tammy or me or anyone else on the Spack team about this, and we'll get you in touch with the right people to help you if you're looking to integrate your packages with Spack test. And in return, under ECP, we're going to ensure that we run the tests frequently on the machines, so you'll get something out of it. Let's see, keep going. Like I said before, we've expanded our CI builds for Spack, and what that means really is that we're trying to cover not just periodic builds of the whole Spack stack, but we want to have CI on every pull request. So the way that Spack works is that there's lots of contributions that come from all these folks in the broader community, and when they submit something to GitHub, we are triggering builds in this server that we run in the cloud. It's called gitlab.spack.io. And we have E4S there. We have a spack.yaml for E4S. And we run this Spack CI command that you can actually run on your own GitLab if you want to for your own environment, that triggers or that generates and runs a build pipeline in Amazon. And so this is testing that the E4S stack builds in a standard container on a standard cloud node. And what we want to do is we were making this a requirement that this pass for every modification to Spack. We want to keep E4S stable over time. And this is really helpful for us because previously, we didn't have this kind of vetting on pull requests. And what that means is that, if a user submits something and it happens to break someone, we don't really find out about it until after the fact, until it's in the main line. And so now we can make this a gating factor on pull requests, and that helps us scale the contributions. It means that whoever contributes the breaking thing is the one who ultimately has to fix it. And we don't have to take that on within our own project. We are trying to add more aggressive testing or a broader set of platforms to test on than just these cloud images. And so there's pipelines at Livermore that we are currently starting to stand up. So Greg Becker is doing that. He's on the call. We're setting up a green test cluster. And this is new for us because historically, all the machines at Livermore have been things that you have to have an account on to run something. We can't just run random code from the cloud on Livermore machines. But with this cluster, we are setting up a place that's intended to run untrusted code from projects in the cloud. And we're planning to run essentially these same tests, but on hardware that we care about and on platforms that are like our production HPC ones. And so we think that's going to get us much broader coverage and much better assurance that E4S and other packages in Spack will be stable on the exotic machines we care about. University of Oregon also has this Frank cluster that you've probably heard about from Samir, and that has a wide range of architectures as well. We would like to do the same thing there. And so we're starting to have a much broader range of machines on which we can do tests. So ultimately, right now, if it passes this AWS pipeline, we can merge it. But soon, if it passes these other two pipelines, we'll be able to merge it back into the mainline for Spack once our little CI test passes. So you may have seen this little icon on GitHub pull requests. So I mentioned Spack environments earlier, and more these are becoming the basis for complex workflows. And so Spack environments are essentially two files with some tooling around them. Spack.yaml, it describes the project requirements. So it's the packages that you need to build. And you saw something like this in the Pantheon demo this morning. And then Spack.lock is essentially the concretized version of this environment. It's all of the exact requirements and versions and configurations of these packages that are going to get installed so that you could reproduce this environment somewhere else. We keep all of that provenance around. In addition to enabling reproducibility, which was the original point of this, Spack.yaml is a pretty convenient way to bundle some configuration with a set of packages. And so we can use it with the features we've developed over the past couple of years to create containers. So there's Spack Containerize, which we did under ECP. There's Spack CI that I showed, which generates pipelines. There's deployment environments where we call them Spack stacks, where essentially you can make a matrix of packages that you want to build. And we have recently added developer workflows to this list. And so we have this new Spack develop command. We had some commands that were targeted at developers before, but not quite like this, where it's integrated with an environment. Spack develop allows developers to work on specific packages within a large project. And as you saw from the Pantheon demo, and as we do at Livermore for all of our multi-physics codes, people don't just work on one package at a time. They might work on one package within a larger code. They might work on several different packages within that code, and they want to make changes to them simultaneously and see how that affects the build and what happens. And the Spack deployment model wasn't quite geared for that. Essentially, Spack was built with facilities in mind where they need to deploy lots of different versions of the same software. But when you're developing a package, you kind of turn that notion on its head. You want to try different configurations. You want to build different ways, but you're kind of changing one instance of the software and converging towards something that works. And so with Spack develop, you can say, activate an environment, add my application to the environment. So that's the whole thing with all of its dependencies. And I want to work on, say, Axum and MFEM. So you say Spack develop Axum at version, Spack develop MFEM at this version. And that gets you the source checked out for those packages in your current working directory alongside the Spack.yaml, so that you could go and tweak this. And when you do a Spack install on this environment, the whole application builds with these versions of these libraries, and you can keep working on them and tweaking them and iterating until the whole stack works. So you can try out new features and so on. So what we're moving towards is we would like this to be an easy way for people to work on essentially multi-physics codes. We want them to be able to check out pieces and work on them in an environment. We have also added Spack external find for developers. So you've probably seen Spack compiler find, where Spack gets on your system and you say, go find the compilers, it goes and finds them from the environment. We are moving towards a model where this is sort of a generalization of that. A package, sort of like how I showed you could add tests, a package can add something called determine spec details. It's a method. And in there, essentially, we run some parallel code that goes out and searches your path for different executables that match these names up here. And we pass them to determine spec details. And then you write some code that says, hey, here's this executable. What version is it? What's the provenance of that thing? And this returns a spec. And so Spack learns from this method per package what's installed in the environment, and it generates code like this for your packages.yaml so that you can have, you can automatically get externals added to your environment. And so like here, this is CMake at 3.15.1. You don't have to go and configure this yourself anymore. You can just say Spack external find CMake, or just Spack external find to find all the possible findable things. And we'll stick them in your environment for you so that you can get a dev environment set up rapidly on a system and use what's already there. So this reduces build time for folks, and it lets you stand things up much faster. The AML team at Livermore, they're working on adding machine learning to and using it with some of our multi-physics codes. They needed machine learning frameworks to run on both our Intel and PowerPC architectures. And so this is sort of a case study of using these features. They needed to use Python, Matplotlib, PyTorch, Pandas, all the whole Python machine learning stack, along with system numerical libraries, GPU libraries, and their usual MPI-based physics codes. And so it's like 30 packages that they needed to build to set up this environment. And typically in an environment like this, everything that touches MPI needs to get compiled from source. And everything that touches PowerPC needs to be compiled from scratch. So we can't leverage, say, the normal Python wheels for some of these packages because they're just not built for that architecture. And every team member has different requirements on Python and PyTorch. And so what they had previously done is everyone built their whole stack from scratch, and they had a script that everyone shared. And people, the scripts diverged. People passed them around. They accumulated modifications and a lot of magic, and days were spent trying to debug differences between the scripts. After they started using Spack environments for this, they have a versioned reproducible stack in a repository where the spack.yaml is versioned. And they have a standard environment for their team in a shared directory. But any team member can get a customized version in about 20 minutes with their own PyTorch version, or if they want to tweak something, they can easily do that with the code here. What it looks like is something like this. Inside the environment, this is sort of one file split out into multiple columns. They listed the packages they needed. They have a list of different preferences for how they want things built. So this is saying what version of mBappage they want, how they want LAPACK and BLAST built, how CUDA should be built, what CUDA architecture to use, and the compiler to use. And then more preferences over here about the different packages in the stack. And with this configuration here, which includes like the compilers they want to use, they were able to version this in a repo and reproduce the environment pretty rapidly. And they're using build caches for this. So that's another feature that the Pantheon folks talked about earlier. Essentially, most of the stack gets built once and cached in a binary cache repo. And pointing the environment at that allows you to not have to build stuff that's already been built by other folks on the team. And for the parts that you customize, that gets rebuilt when you build this environment. So it makes it easy to work on pieces of the environment, tweak parts, and diverge where you want to, but at least share all the common work in a build cache. All right. So Spack 0.16 is our latest version, and 0.16.1 is a bug fix that we released in February. The major new feature in this version were some of the things I've talked about just now, and then the new concretizer. And I'm going to talk a lot about that for the rest of the presentation. So the new concretizer had gotten pretty complicated in Spack. And for folks who don't know what this is, if you say Spack install HDF5 at some version, or if you say install it with this compiler, there are a lot of rules in Spack that come from the package files from the command line, from environments like the one that you just saw, that say how you want something built. And integrating all those rules is pretty complicated. The old version of the concretizer would do this sort of iterative graph building algorithm. It did not have a lot of backtracking in it, and often it could make a decision based on a rule in one package that would then be contradicted by a rule in another. And so that was bad because users would sometimes get wrong answers out of it. It wasn't sound. It was what we could build at the time. And so we had been using this sort of fixed point algorithm for a while. It does not scale to all the criteria that we care about in Spack. And I think, with the ecosystem growing and the number of constraints and packages growing, we needed to do something else. So, based on that, you can probably infer that build configuration is really its own many-dimensional constraint optimization problem. It's an NP hard problem to take all of these different version preferences and things from different packages and to put them together into a consistent build. And the new dependency solver that we introduced in Spack version 0.16 allows us to solve this problem using answer set programming, which is, it's a high level sort of modeling language that looks a lot like Prolog, but it boils down to SAT on the back end and SAT plus optimization. So essentially we can take all the constraints, we can express them in terms of these sort of Prolog predicates over here. And we throw that into a solver and come out with a consistent answer. And that gets us backtracking, that gets us much more complex logic around things like conditional constraints and stuff in our packages. And it lets us resolve dependencies way better. What it looks like from sort of, at least our perspective as developers in Spack is, instead of doing this iterative graph algorithm where we have to build a bunch of Python objects and mess with all that at runtime, We just iterate over the packages, the requirements from the users and so on, and we generate this large list of facts. It looks like this over here. And you can see like up here, this is a list of version preferences for UCX. This is the description of a variant on UCX. These are descriptions of dependencies. And there are things like descriptions of conditional dependencies and stuff like that in here as well. All of those facts, there's typically 20 or 30,000 of them for the typical package in Spack. And this is coming from that package and all of its dependencies. We're essentially taking all the information about anything we could possibly depend on and throwing it in the solver. We take that, we combine it with a small logic program that has about 800 lines of code. This really defines the core semantics of how Spack does dependency resolution. It's 300 rules and about 11 different optimization criteria. And we do a solve. And what this finds us is something called a stable model. That basically means we find a model that fits all the rules. We find a model that where all the rules are idempotent. And we take that and we build a new graph out of it. And it's really cool what this has enabled us to do. If you look at the top 6 most wanted features in Spack, they are tied to this capability. We want to be able to reuse existing installs, which is essentially optimizing for how many packages that we see either in a build cache or installed on the system already. We have to be able to solve an optimization problem where we try to use as many of those as possible and satisfy their constraints. Better flag handling requires us to be able to manage constraints on flags over packages, developer support. A lot of these things are tied to the capabilities in the new concretizer. So we needed this aggressive capability to support what people are starting to want from Spack. And it really enables significant simplifications to packages. So and this is evident in some of the SDKs. We talked to Chuck Atkins about his Viz SDK. And while they're not using this stuff yet, they're waiting for the new concretizer to be default. These are just some examples of how you can simplify your package with the new system. Before, because the algorithm wasn't really complete, you had to sort of combinatorially expand combinations of options on your package. So if you require, if you have a package that depends on another package foo, and you have sort of options that you want to pass down through there, you would have to say, well, when I have A and B, foo also has A and B. When I have A and not B, foo also has A and not B, and so on. With the new concretizer, you can write that in 3 rules that are much easier to read, and you can really understand what's going on. The thing is smart enough to make sure that all of these are satisfied and that it tracks them throughout the solve. Other things like specializing rules for particular dependency choices didn't work. So if you depend on BLOS, but when you depend on OpenBLOS as your BLOS provider, you need to use OpenMP threads with it. It was hard to write that before, and it was really hard to get right. And so, and often people would work around it by adding more options to their own package and so on. And it wouldn't really be stable because the algorithm was greedy. There would be some situation where the constraints weren't properly applied if you got a big enough graph and enough complex dependencies. So now you just write that you depend on BLOS and you say, when I depend on OpenBLOS too, then I use this thread model. And the solver is smart enough to enforce constraints like that. So we've seen a lot of different fixes like this across the stack. We have like a tag for things that have been fixed by the new concretizer, and we're continuing to improve it to make sure that the semantics of the solves match what people expect. And I think it's been really productive. We're going to be releasing 0.17 in the next 1 or 2 months. And the main goal of 0.17 is to get rid of the old concretizer. We find ourselves still having to support that, and a lot of bugs are fixed by the new one. We want to be able to make the new one the default, and I'll talk about why that's complicated on the next slide. We want to improve and harden binary cache workflows. So like we do have this binary cache capability. I would say that at the moment it takes a little more setup than we might like. So we're continuously improving that and trying to make it easier to use build caches and to get the kind of speed that you saw in the Pantheon workflow and some of the other tasks that the E4S folks have been doing. We are trying to get shared Spack instances for facilities in there and make them more manageable. This requires sort of rejiggering where Spack stores its internal data and being careful about where we write things so that we don't write to a read-only directory, for example, for a facility deployment. And then finally, we're trying to get rid of pain points for users. So we found that the configuration in the home directory has been a problem. So for 0.17, like I said, the main goal is bootstrapping this new Klingo dependency that we have. That's the solver. And in 0.16, it's experimental. You have to bootstrap it yourself. You have to install Klingo and then set up Spack to use it if you want to try out the new concretizer. 0.17 will remove that entirely and make it so that we can bootstrap Klingo either from source or from binary. And so Greg and Massimiliano Filippo, one of our collaborators, have been working on streamlining that process so that instead of you having to set up a C++14 compiler, we will just have portable static C++ binaries available, or statically linked C++ binaries available, so that you don't have to build this thing, and so that Spack can just have that available to it automatically. Making that work in all the contexts where people use Spack has been an interesting adventure, but I think it's going to be worth it in the end, because we really want to preserve the property that if you clone Spack from the repo, you can just go and use it right away. The fact that it was pure Python before made that an easy thing to do, but I think people rely on that, and so we're trying really hard to make this a smooth experience when we make the new concretizer default. And so you can see here, this is one of the GitHub pipelines that we are using to build that. We have taken a page from the way that the Python folks build portable binaries to do this one kind of lowest common denominator binary to bootstrap the whole stack. So that's what this many Linux thing is for. The other things, I mentioned these a little bit, sharing a Spack instance. We want users to be able to module load Spack and install by default to their home directory if it's a facility installation. And then we want them to be able to leverage the stuff that the facility has installed without a lot of configuration. And then users have been bitten by having multiple instances of Spack or cloning something and having some stale configuration in their home directory. You will still be able to make global configuration to Spack, but it will be per instance. And so like if you would need to modify etc/Spack in the Spack installation itself to get that kind of global configuration. And I think that's a lot more clear. You'll still be able to have sort of per project configuration, but what we're encouraging folks to do for that is to move to an environment to get that. And so what this will do is it'll mean that there won't be one global configuration scope that quickly goes out of date in the home directory. And for use cases like CI, where you're cloning the repo constantly, it eliminates the risk of there being stale data there, and it makes the whole stack more reproducible. So we're trying to get rid of that. For 18, we've talked about this a bit before. We would like to have compilers as dependencies. And so we'd like you to be able to depend on C++ versions and C++ features, OpenMP versions, and so on. That is something that really needs the new concretizer to work. And so we're pushing this to 0.18 because getting it in the main line, we have a prototype of this right now, it really needs that new concretizer to be default to work well. And so we're going to get that done first and then move to compilers as dependencies as a follow-on. And then just in other news in the Spack community, alongside the ECP and ASC Spack projects that we already have, we are starting a research project called Build. And the premise here is that the Spack is a big ecosystem, and there's a lot of constraints and packages and version rules and things that humans have to maintain. And frequently the version constraints in Spack packages can be wrong. And we can't rely on people to set all of those correctly. So what we're aiming to do with Build is to really take a stab at understanding software compatibility, what goes into making packages compatible, particularly at the ABI level. And so instead of the human-generated constraints that can get quite lengthy in packages right now, what we would like to be able to do is examine a binary, look at the functions, the exit and entry functions of the binary, understand their ABI either from the debug information or from binary analysis, and understand compatibility from that perspective as opposed to from just versions provided by people. And so we would be inputting this stuff to the solver and doing a resolved ABI compatible graph based on that. And the cool thing about this is that we could at least guarantee you that it would link and that the types would be ABI compatible if we're successful. So this is a long-term project. It's going to wrap up in 23, but this is where we're going. We are really trying to improve life for folks who do integration across languages, and that's what we're working on. So yeah, and I guess there's no FOSDEM talk on Sunday, so I'm going to delete that. But you can find the FOSDEM 21 talk on this if you want to get more details. And with that, that's the presentation. So thanks a lot, and we'll open it up for questions.
Okay, so there are a couple of questions, Todd. We had someone asking if you're going to post the slides.
Yeah, we will. We're going to put them on the session list in the webs on the ECP Confluence.
Okay. And then we have some questions about using the concretizer.
Yep.
So Cyrus is asking why fully remove the old concretizer couldn't help in a pinch if there are surprises, he says.
We could leave it there as an option. I think we will make the new one the default, but we want to move away from it because right now we see a lot of issues that people bring up that are just broken in the old one and that are fixed by the new one. So that's what we're trying to. We're ultimately going to try to have one code path. So yeah, I mean, maybe we will leave it in as a default if people insist.
Okay, and then there's Alicia is asking, does it mean that 018 will have packages that don't depend on a compiler?
So that is the idea. With 018, if we make compilers into dependencies, like I'm saying here, let's see. Yeah, you would essentially, we would make compilers into dependencies that would be found via Spack external find as opposed to Spack compiler find. And you would just say, I need C or I need Fortran and have some extra constraints on top of that. And if you don't say that, then we just assume that you don't need those things. So that would enable packages that don't have a compiler.
Okay, and there were a number of answers to that in the meantime, but those are the only questions I see so far in chat.
Okay, I realized I forgot a slide, so let me get to that. The one last thing I wanted to mention is that, geez, let me fix that. Greg actually told me about that, but I forgot to fix it. All right, tomorrow we do have a Spack tutorial, and I think it should be of interest to most folks here because it covers a lot of the workflows that I talked about. So Robert Blake, the guy who did the machine learning workflow that I showed earlier, has revamped the back end of our Spack tutorial. And so we've moved environments to the beginning, and we've sort of reworked the beginning to be more in terms of environment-based workflows. And the second half of the tutorial is on these Spack developer features that we had talked about. So if you want to know how to get your application working with Spack, come to our tutorial tomorrow, because I think there's a lot of new good stuff in there. All right, so back to questions. I guess we can just open it up. If there's nothing else in chat, then let's just, I mean, if people want to ask questions directly, go ahead, unmute and fire away. Anybody?
Hey, Todd, do you have if we can't make the whole tutorial tomorrow, do you roughly know what time the developer section would start?
The developer stuff will be in the afternoon. So it's the second half of the tutorial.
Thank you.
So let me think, 10, 11. Greg, do you know what time the second half starts?
I can judge that, but yeah.
Not off the top of my head, but it's going to be around noon Pacific time.
Yep.
Around 3 p.m. Eastern time. Yeah, give or take. I mean, the halfway point,
yeah. Give or take,
should be halfway through lunch.
Okay.
It may be a little earlier than that, I think, because it ends at 3, right?
Yes.
Yeah, so it's probably more like 11:30, but yeah, go ahead. There's a break in there, right?
Yes, there are 3 breaks in there, but.
Okay. Any other questions?
Oh.
So Cameron's asking about sanity checking. Oh, and it was answered YAMLint.com, sanity checking someone's Spack.yaml indentation bugs and things like that. So they're asking for a recommendation for tools.
Oh, is that Shazab?
No, that was Cameron Smith asking about it.
Oh, interesting. Okay. I guess we do. I mean, we do have a schema for Spack.yaml, but we don't really have something that you could run to just validate it right off the bat. Is that something that people would want?
I mean, there are certain features that you cannot use Spack to add to a configuration.yaml. I mean, I know Rob Blake just said he uses that, but like if you want to add the fact that you want to concretize together, to the best of my knowledge, the only way to add that feature is to hack it manually into the YAML file in an environment. And so, yes, having a way to make sure that the YAML file is sane would be great.
Okay, cool. So yeah, we could, yeah, let me put that down on the list of that. I think that would be pretty easy to do, to just, you know, I guess like the obvious way to try that is to just do a Spack find in the environment. But yeah, we could add something to just that has the sole purpose of validating the YAML.
Yeah, because if the YAML fails, then your entire environment is borked until you figure out how to fix it.
Yeah, and you could stick that in CI on like a Spack environment repo. That would be super useful.
Yeah. Another issue along those same lines is if you want to add compiler specific flags to your environment. So let's say, for example, I worked at Livermore, and let's say, for example, that the default compilers at Livermore were archaic. And let's say, for example, I want to build with Clang and I need to actually pass the GCC tools, a toolchain flag to Clang. The only way I know how to put that into the compiler I added to my environment is with like sed. So again, you provide these nice flags and I can do it once for myself, but if I have it in a workflow for an entire team, you get into this, I'm manipulating my YAML file or somebody else's.
Yeah, okay. Yeah, that's fair. Is that really an example, Brian, or is that something that actually happened to you? Because it seems awfully specific.
It seems to be happening daily. On the same lines, actually, this is going back to the .spack issue. So I'm trying to push people to try and use the new concretizer for installing LBAN. And I had somebody who started from scratch, and I'll say that in air quotes, because they've tried Spack before, I believe, and they get some bug and Nickel didn't build happily. And of course, this becomes my problem because I told him to use Spack. Is there a way to just have them have Spack ignore what it finds in the user's .spack directory?
Not at the
Yeah. So the way I do it, Brian, is there's a single line modification you can do to the Spack configuration in the like where they set it up. Just give them a patch to apply to the Spack source tree, and it will do it.
Okay.
But soon there will be an actual supported option that is not running sed on Spack.
Yeah.
It's not there yet, but it's part of the shared user or the shared Spack support that Todd was talking about, allowing people to module load Spack. As part of that work, we've changed the defaults in terms of how config work, and that work, you know, we say things, you know, this is happening in the future, that's happening in the future. In terms of time frame, that work is already in code review. Someone's done it, it's there. It's just a matter of, you know, ironing out the final details and getting it merged at this point.
Yep.
Sure. And Rob, can you please send me the sed script for that?
Yep. Yeah, it's really easy. I also wanted to ask a question. Occasionally when I'm using environments on a shared file system, I run into a problem where it can't remove the bin directory of the .view of the Spack, and just because of file system contention blocks, right? It wants to remove something, and like there's a .nfs in the directory, and it can't remove the environment to redo it, and then that causes the whole environment to break until I like rm-rf the .spack env directory.
Yes, speaking.
How do you deal with that though? So I'm not actually sure that I don't know how to get rid of the NFS lock files other than like moving the whole directory and blowing it away and starting over.
This is the great thing about being a user is I don't know how to deal with it. I just complain.
I mean, I'm trying to think of, I've hit that problem with not just Spack, but other systems too. And I guess we could put some smarts in Spack to, like, if it sees an NFS file, to just move the whole environment directory out of the way and make a new one.
Yeah, that's typically how I deal with it. I move the environment directory, or I wait 5 seconds and then I can remove it.
It just seems very sad to have an NFS garbage directory that we move
Yeah.
lock polluted environments to, but that's the only solution I can think of that would work.
Yeah, that's what I do.
So on a similar related note, I have had problems where because I hit my Spack repo a lot frequently and update it and go to different PRs and stuff like that, I've gotten in a situation where Spack is not clear about the existence of packages or what their hashes are, or they don't exist, but they do exist in some aspect, be it an environment or YAML or something like that.
Yes.
And I learned a long time ago that I don't really love deleting all of my Spack and starting from scratch, and I try to discourage users.
We don't like
So
that either.
I want a Spack really effing clean command. Like, go through and delete everything you possibly can and clean, except for like maybe your config files, but really delete all the build caches, all the install caches, and the environments. Yeah, that's a more polite way to put it, Harrison 37. But I just found that I've gone and I've worked with the team here to say, well, how do we figure this out? And sometimes it's just obtuse about. And I think what was happening in my particular one was a hash existed in an environment, but a recipe had changed, so it hashed to a new thing, and then it just couldn't figure it out.
Is this a patch
and
hash or is this a package hash?
Package hash.
Yeah, I've seen that. Greg, do you want to? You've seen this issue, right? You want to comment on that one?
Yeah.
I probably talked to Greg about it.
Yeah. The issue is related to the
I guess
so
before you
environment.
I'll say, like, I don't think that is related to real clean. So go ahead, Greg.
The issue is that environments cache a lot of concretizations for performance, because if you reconcretize everything in environment every time you add something, you're going to have a bad time. It's going to take a long time. So in general, I believe that this issue is resolved by Spack concretize-F in the environment in question, because
Okay.
that removes all of the cached stuff.
And reconcretize
So-
the whole thing.
Yeah, without trying to problem solve too much on the call here,
Mhm.
a Spack clean environment concretization flag, because I have like 50 environments because of how we do our builds, so I can get a lot of them, and I don't know which one's the failing one. So just something to go clean up all that concretized state, if I ask it to, would be great.
Another option to Spack clean to do that.
Yeah, that's what I'm saying.
Like
Yeah.
a Spack clean,
Yeah.
remove all the lock files.
Yes.
Because essentially, I mean, like,
exactly.
really, like, for that particular problem, like, just removing the lock file will get rid of the stale concretization.
Yeah.
And so, yeah, we could add another. I guess, are your environments known to Spack, or are they in directories?
They're all known to Spack.
Okay, so they're named ones that you've managed inside of. Yeah, okay. So yeah, we could
Yeah,
add something that goes in and removes the log file from all of them.
Yeah, for me is, I can figure out how to do this now that I've gone through it once, if I remember next time it happens, but just an ability for another user to say, go clean up all the environments would be great.
Yeah, we should also track down what exactly that problem is, because honestly, like, an unknown hash should just be something that we respect and don't complain about. So that's two things we should probably do.
I have a couple questions if that conversation is resolved.
Yeah.
One is more broad and the other's quite a bit more specific. I'll start with the broad one. Do you or anyone else on this call have any lessons learned from really quick package development, usually in the earlier stages of package development? For example, we started out just having Spack forks for the packages and making changes really quickly. Then we ended up moving to having a separate repository, which was also a Spack repository. So we would tell users to get the newest stuff, clone it, and then Spack repo add dot. to iterate really quickly. I don't know if anyone had any kind of better solution to that or any lessons learned or ideas for us to use.
So if your repo has a Spack.yaml in it, it can just be an environment. And with Greg recently got relative paths working for that. So you can actually just in your Spack.yaml, you can say repos : and then have the location of that package repository that you made in the repo too. So you can have like /packages is my repo. And then you don't have to have them set up anything. The config is just bundled with the environment. So that's the only improvement I can think of off the top of my head on what you're doing.
Yeah, I would, when I am doing quick Spack development, making a new package, what I'll typically do is do Spack develop on, I'll make up like a template package and then I'll do Spack develop on it. And that makes it so that when Spack goes and does the build, I actually don't have to go to the var temp directory to see what Spack tried to do. It's all there in the same place. And I just hack on the package. I actually end up using Spack develop more to hack on a Spack package half the time as opposed to hacking on a piece of source code, because it lets me look at the build right there. And once I get that working, I push it to a private repo and just point the environments to that repo.
Okay, interesting.
Yeah,
Yeah.
the Spack develop is actually really nice if you're writing a Spack package, because it will build the source code right there and you can look and see what it's doing. And like if you have to modify the source code to put a patch in, yeah, I can modify the source code right there, get it working with Spack, and then do a git diff to get a patch file that I then put into the Spack package.
I see. Okay, very cool. Yeah, I'll have to look into that. Thanks. Other question was just about configurations. I mean, so your Spack instance can pull configuration options from all these different places. And sometimes I'll find some problematic option and I can do, Spack config get config or some particular config, and I'll find the problematic one and then tracing it back to the place whence Spack got that option is just a huge pain. And I have to.
Oh, have you tried Spack config blame config?
No.
Because that
like
exists.
that
Here, let me demo that. Here people maybe don't know about this, but there is a command for this purpose. And so yeah, if I just do config blame like this, it shows you the annotated configuration along with where it came from. So here's what you would get from config get config over here. And then these are the files that it came from and the lines in them. And they're color coded so you can see the different files easier. Can you see that?
Yep, that's precisely what I was asking for.
Awesome.
Awesome. Thank you, guys.
On that note, like, I guess since we're talking about blame, I don't know if you know this, but you can also say Spack blame HDF5, for example, and get a list of whoever's contributed to that package and how much of the package they contributed. So if you want to find someone to help you with something, this could be useful.
Interesting. Okay. Yeah, that's another good option. Thanks.
It's not really related, but it's also blame. We have a lot of blame. Any other questions?
We should have an alias to praise.
Oh yeah, but that's no fun. I guess we could advocate.
I was wondering the last time I seriously played with Spack, my cluster had a Spack installation and I wanted to reuse their compiler configs. And so I wanted to do a staged or like a chained Spack installation where I have my own local checkout, because of course their Spack installation is not writable to me. But I think I needed to copy over the compiler configuration instead of just pointing it to it as a upstream information.
That is interesting. So Greg and maybe Peter, do you guys know if the shared Spack stuff, if that PR, which changes upstreams quite a bit, actually allows us to chain the compiler configuration? You would get the compiler configuration from the upstream install tree in that scenario, right?
Yes. So you could associate, so there is now, or as part of that PR, there's a scope associated with the upstream installation tree.
Yeah. So essentially with that PR, we will move a lot of the configuration to be associated with a particular install tree. Because right now there's kind of a disconnect between the place where the packages get installed and the instance that's doing the installing. And really like you want, since other Spack instances can reuse the installations, we want to solve this problem that you're talking about by moving the configuration into the install tree. So I think that'll get fixed with 0.17.
Okay, cool.
And upstreams will be easier to configure. That was the other thing that PR solves.
Wait, you know what? I'm actually sorry. I'm thinking again. I'm not sure if we would pull the configuration from the upstream installation tree.
For
the
compilers,
local installation tree, because I don't know if we create a scope for every tree that we use.
Okay, well maybe we'll think about that as we review that PR, because I actually think that's a common request from users is like, what compilers do I use on this system?
Yeah, and it's similarly, I think it was also that the upstream Spack was providing system installations of CUDA, and I had to reconfigure them locally.
Yeah. Okay, thanks.
For the packages config, there's a new option to Spack config prefer upstream that will generate preferences for your local Spack instance that will point to the packages in the upstream, but that doesn't handle the compilers.
Yeah, it'll at least get fixed in 0.18 because the compilers will just be dependencies governed by packages.yaml. So there's that, but I think it's a good point that we ought to look at before 0.18.
I have a request for a feature that I would really like.
Okay.
When I run Spack external find, it adds a whole bunch of stuff, including Go, to my Spack external or to my environment YAML. And very rarely do I actually want Go or the other 200 things that get added to my environment. It would be nice if there was like a Spack external find variant or something that would just add the variants that are in my current dependency tree.
Can you, so you mean, okay, so you set up your environment, you put the roots in it, and you want it to only external find potential dependencies of those things?
Yes.
Okay, I will say, so I like that idea. I think that's interesting, but I will point out that like HDF5 even has like hundreds of possible dependencies. Like it's got like 400 if you look at the whole expanded graph. So like, and I guess we could trim that down by not exploring build dependencies or dependencies of build dependencies. That may be the right way to do it.
Well, so the other thing I will say is that,
right?
Well, I mean, right now, not all packages have external detection to them.
Yes.
So it doesn't really matter.
True. Yeah, okay. So, and I suppose probably Go is not an indirect dependency of HDF5 in any universe.
No.
We could also do it as like a breadth first search on the DAG and not explore anything beyond where we find an external.
Yeah, or I think, yeah, that and I think we should search for build dependencies of stuff that's either a run or link dependency of the roots, but not descend into build dependencies, because then I think you can get all sorts of weird dependencies that way.
Oh, I would definitely want build dependencies. Like the biggest thing,
you'd get the build dependencies. So but only if, so you suppose that like HDF5 is your root, right? And it can depend on CMake to build it, or one of its link dependencies could depend on CMake. We would look at CMake, but we wouldn't like say, oh, CMake can potentially depend on Qt, so let's go detect that too. We would just stop.
No.
CMake,
right? Yeah, stop CMake. Yeah, exactly. Because right now I have a monster command I paste in that contains like autoconf, automake, M4, all the typical things, and say, just give me these externals.
Well, if you hadn't added so many useful features to Spack external find, it wouldn't find all those things. So,
I mean, perhaps we could just, it sounds like you have a notion that like you specifically, you use the phrase, the typical things like autoconf, etc. I suppose we could add those, we could add an explicit listing like that to Spack external find itself.
Well,
'Cause I think a lot
I
of people
think
would
the
probably
typical
say that.
things differs for different projects.
Yeah,
Different
okay.
projects have different typicals, and
Okay,
like the
all
most
the things you mentioned sounded like typical things everyone would consider typical. So I don't know.
Not if you don't have like an auto tools package in your project, right? Like if you happen to have, you know, an environment that doesn't depend on auto tools at all, I think Rob's approach makes sense. Like we could cut it off at build dependencies, and we could just look at like what the link and run dependencies of the roots are and stick to that.
There are going to be some people who use Python exclusively who don't care about any of the things that the rest of HPC considers typical.
Yeah, exactly.
Yeah.
I think it is like dependent on what the roots of your environment are, like what your main requirements are. So yeah, well, let's try it and see how well it does, Rob, and then you can be our guinea pig as usual. Any other questions? Okay, well, if people are done, it's 11. We've got 30 more minutes scheduled, so if people have more questions they want to ask, feel free, but otherwise we'll just call it. All right, thanks everybody.